we all need pep talk. The world needs you to stop being boring. Yeah, you. Boring is easy. Everybody can be boring, but you're gooder than that. Life is not a game, people. Life isn't a cereal either. Well, it is a cereal. And if life is a game, are we on the same team? I mean, really, right? I'm on your team, you're on my team. This is life, people. You got air coming through your nose. You got heartbeat. That means it's time to do something. A poem. Two roads diverged in the woods, and I took the road less traveled. It hurt, man! Really bad. Rocks, boards, and glass. My pants broke. Wah! Not cool, Robert Frost. But won't they really work too fast? I won't be the one that leads to awesome. It's like that dude Journey said, don't stop believing, unless you dream stupid. Then you should get a better dream. I think that's how it goes. Get a better dream and keep going. Keep going, and keep going. Well, Michael Jordan have quit. Well, he did quit. So he retired. Yeah, he retired. But before that, in high school, what if he quit when he didn't make the team? He would have never made Space Jam. And I love Space Jam. What will be your Space Jam? What will you create will make the world awesome? Nothing if you keep sitting there. That's why I'm talking to you today. This is your time. This is my time. It's our time. We can make every day better for each other. If we're all on the same team, let's start acting like it. We got work to do. We can cry about it, or we can dance about it. We were made to be awesome. Let's get out there. I don't know everything. I'm just a kid. But I do know this. Everybody do to give the world a reason to play. Get to it. You just did a pep talk. Create something that will make the world awesome. Play ball.
Welcome back, everyone. Hopefully someday you get to make your Space Jam too. Love that movie. But here we go. We're going to take a look today at some simple ideas, okay, with simplifying polynomial expressions. Today we're only doing adding, subtracting, and foiling. That's our big thing. So we're going to take a look at this. All right, I'm trying to make the camera come in a little bit closer because I know these are really tiny, so if it looks real zoomed in, that's what I'm going for. Okay, let's see here. Rules for adding, subtracting, and multiplying. When adding, you can only add together like terms, same variable, and same exponent. So here's an example. 2x squared plus 7x plus 1 plus the quantity x squared minus 2x plus 8. You are only combining like terms. So 2x squared plus x squared gives you 3x squared. 7x plus or minus 2x gives you 5x. And then the 1 and the 8 gives you 9. All right. So let's see an example over here, something we can come up with. I'm going to go with 5x squared plus 3x minus 2 plus 4x squared minus 5x plus 6. Just picking random things. I love underlining things, underlining like terms. It makes your life extremely easy. 5x squared plus 4x squared gives me 9x squared. 3x, I'm going to do 2 underlines here, minus 5x is minus 2x. And lastly, negative 2 plus 6 gives me plus 4. Okay? All's well and good. Let's see here. When subtracting, okay, you can only add like terms again. So this here, the minus sign gets distributed across. So it turns into negative 2x cubed minus 9x squared minus 2x. And then I combine together like terms. Okay, so that ends up being negative 6x cubed. Negative 5x squared minus 9x squared gives me negative 14x squared. And 2x minus 2x is 0. So here's an example. I'll make it real simple. X squared plus x plus 1 minus, let's go x squared plus 2x minus 4. So if I rewrite this out, x squared plus x plus 1 minus x squared minus 2x plus 4. Make sure you're distributing it all the way across. I can combine together like terms. X squared minus x squared is 0. X minus 2x is negative x. And 1 plus 4 is 5. Okay? Cool. Finally, the last thing we're going to take a look at in this video is something called FOILing. Okay? When multiplying, you must multiply all elements in the first polynomial by all elements in the second polynomial. For a binomial multiplied by another binomial, you use the FOIL method. I'm going to show you guys a quick example of FOIL over here first, and then I'll show you this tougher example. Alright, FOIL. You want to do first, outer, inner, last. And I always draw a FOIL, dude. It looks like a little smiley face. Yeah, it just makes me smile. X times x gives me x squared. That's my first. Outer, x times negative 3 is negative 3x. My inner is 2 times x, which is 2x. And my last is 2 times negative 3, which is minus 6. If I combine together like terms in the middle, I get my final. X squared minus x minus 6. Okay? So the first, F stands for first, outer, inner, last. It helps jot that down. We can take this one step further. Okay? And if I have a binomial times a trinomial, 2, 3, you can multiply the x all the way across, and then you can multiply the negative 2 all the way across. This takes a little more work, but let's take a look and see how it goes. X times negative 2x squared is negative 2x cubed. X times x is x squared. X times negative 4 is negative 4x. Now, the negative 2 going across. Negative 2 times negative 2x squared is plus 4x squared. Negative 2 times x is negative 2x. And then negative 2 times negative 8 is plus 8. If I add going down then, combining like terms, negative 2x cubed, x squared plus 4x squared is 5x squared, negative 4x minus 2x is negative 6x, and then plus 8. Okay? Alright. So we are going to take a look at some examples down here. We'll see how many we can get in our video. Alright, so here we go. Part A. I can distribute this minus sign across to all three terms. It becomes minus 4t squared, minus 10t, and plus 9. Now I'm combining like terms. 7t squared minus 4t squared is 3t squared. Negative 3t minus 10t is negative 13t. And then 5 plus 9 is 14. Done. You can't combine together any other like terms. You're good to go. Okay. Over here, we have a lot of different variables going on, but keep in mind it has to be exactly the same. So can you guys see how there's only one y cubed? Like there's only this y cubed right there? So I bring this down, 5y cubed. And if you look, the only thing that can be combined together is the 3x and the x. Everything else is just unique. So I keep everything else exactly the same. Minus y squared plus 3. 3x plus x gives me 4x. Minus 4x squared plus x cubed. Nothing else can be combined together because they're all different. And that's it. Okay. That example is just to show you keep things separated. Alrighty? Now, please note that for these first two I had a minus and a plus sign in the middle. Do I have a minus or a plus sign in the middle here? I do not. So then I know I have to FOIL. Okay? First, outer, inner, last. I always love drawing FOIL, dude. X times x is x squared. X times negative 1 is negative x. 8 times x is 8x. 8 times negative 1 is negative 8. And the beauty about FOIL is that typically in the middle, my outer and inner terms can be added together. So I get x squared plus 7x minus 8. Boom. I'm all good. Okay? Awesome. Alright, moving on. Here's an example of the harder one. The x can get multiplied to all three terms. The negative 5 can get multiplied to all three terms. Here we go. Negative 2x cubed plus x squared, x times x is x squared, minus 4x. There's my x being multiplied to all three things. Let's do negative 5 now. Negative 5 times negative 2 is positive 10x squared, minus 5x, plus 20. Okay, add like terms. And we are in tremendous shape. Tougher problem, definitely something you guys can handle. Okay, part E. Again, I've just got a binomial. Recognize the problem first. We're going to do our FOIL. So 9m times 3m is 27m squared. 9m times 1 is 9m. Negative 4 times 3m is negative 12m. Negative 4 times 1 is just negative 4. And lo and behold, outer and inner can be added together again. 27m squared. 9 minus 12 is negative 3m. Minus 4. Okay? Making good timing. Just 4 more to go here. The negative x squared can get multiplied across. This is just called distributing. Distribute. Negative x squared times 12x to the third. Remember, you add the exponents. Negative x squared times negative 11x squared is positive 11x to the fourth. Negative x squared times 3 is negative 3x squared. Nothing can be combined together. Boom, you're all finished up. Down here for part G, I can again just multiply this 9 into all three terms. It works the other way too. Like here you see how it's out front and here it's out back. 9 times 5k squared is 45k squared. 9 times negative 2 is negative 18k to the fifth. And 9 times 4 is 36. Okay, I know I'm going through these relatively fast, but if you need to, pause the video, feel free to rewatch it, or ask questions in class. H. Okay, foiling. 8 times x is 8x. 8 times 2 is 16. Negative x times x is negative x squared. Negative x times 2 is negative 2x. So I'm going to write the negative x squared out front. And then my 8x minus 2x can go in the middle. Minus 6x. I'm sorry, plus 6x. And then plus 16. It's just called a standard form, by the way, when you go from x squared to x to down. You always want the highest exponent going down. Okay, so like over here, I would want to probably put the negative 18k to the fifth out front, then the 45k squared plus 36. Just a good way to write it. Keeps things uniform. Last one, part I. I can distribute the x into the first set of parentheses. I can distribute the 2 in the second set of parentheses. X times x is x squared. X times 3 is 3x. 2 times k is 2k. 2 times x is 2x. Combine like terms. There's only 1x squared. 3x and 2x gives me 5x. And then plus 2k. And I can't really combine anything else together, so I'm all set. Right? So we did a lot of problems there, okay, and it's a lot of good problems. But you'll notice it's the same idea every time. All right, so give your classwork a try, give it a go. If you have any questions, please feel free to ask. Keep up the good work, and as always, good luck. We're all counting on you.